Okay, rationalizing the denominator, or rationalize the denominator. We are going to have a look at that in a second. First of all, we've just snuck in an extra rule here that we haven't looked at before, but it's pretty straightforward, and it's just like the multiplying rule we use for simplifying, where two separate square roots multiplied can be multiplied together in a single square root, where it works for dividing two. If two square roots are being divided, then you can put them in a single square root divided as well. Or, of course, take them out of it and put them in. But in this case, we're mainly going from this to this. Okay, so I'm going to put the pause button on. I want you to have a go at those four. It's pretty straightforward, so just see what you come up with, and let's see what happens. So press pause on the video now and do these four, and then unpause when you're done. Okay, so we've unpaused. Let's see what we've got for these then. Okay, so we got two square roots that are they are divided separately, so I'm going to put them together. So 30 over 6. Well, 30 divided by 6 is actually 5, isn't it? So this simplifies to root 5. See? Straightforward. Tick. Happy smiley face. This one, we can do the same thing. Two separate square roots separately divided in a fraction there. Well, we can put them in their own little fraction inside the square root. 28 divided by 7 is 4, so we can change that to 4. But oh, look, square root of 4 is 2. So actually that simplifies even further to a non-surd. Which is interesting because there was a surd in the denominator there, but now there's not. Weird, huh? Okay, this one. Now we can do this interestingly. We can actually put this as 3 times the square root of 6 over 12. And that is going to be 3 times the square root of a half. All of that is in that square root, okay? So 3 times the square root of a half. Now, initially, that doesn't look particularly useful, does it? But let's think about this. We can go backwards on this and separate it out again, if you're being sneaky, into two separate square roots. So 3 times the square root of 1 and square root of 2 underneath. Yeah. And now the square root of 1 is 1, because 1 times 1 is 1. So 3 times 1 is 3 all over root 2. You see? If you don't believe me, we could try this on a calculator as well. So 3 square root of 6. I mean, this is like the worst radio in the world, isn't it? Basically, someone typing stuff on a calculator and telling you about it. But it is right. It is right. Okay. Right. Okay. So anyway, yeah, just take it from me. It's fine. Now let's have a look at this. So we can actually do 8 divided by 2 first of all to get 4. We can just do that division straight away. That's nice and straightforward. And the third part of it can go into its own little fraction inside a square root, 24 over 2, which will be 12, won't it? 24 divided by 2 is 12. So 4 lots of root 12. Now root 12 though can be simplified, can't it? Because it can be simplified to 4 times by 3. And we can put those in separate square roots. I don't know why my computer's being really weird recently. Don't know why. And then, of course, that simplifies to 2 root 3. We've simplified root 12 a lot. Which means I've got 4 lots of 2 root 3. Well, 4 lots of 2 is 8. So it's 8 root 3. Yeah. 4 lots of root 12. So 4 lots of 2 root 3. 4 lots of 2 is 8 root 3. Yep. Tick, tick. Anyway, let's move on to rationalizing the denominator. Okay, so what we mean by this is currently the denominator, the bottom number, is an irrational number. It is root 5. We don't like that as mathematicians. The explanation of why is a bit tricky, but just we don't like it. So we have a thing where we like to rationalize it, turn it into a rational number. And I can't just ignore the square root, it is there. Now an easy way to turn that square root into a proper number there, into a rational number, is to actually times it by itself. Because remember, what happens if I times root 5 by itself? Well, root 5 times root 5 is 5, isn't it? This old rule 2 over here. But it's a fraction, so whatever I do to the bottom, I must do to the top. And if I do that to that, I'll get 1 times root 5, which is root 5. I actually get an equivalent fraction, don't I? If you do something to the bottom, you do the same to the top, you get an equivalent fraction. I'm actually timesing it by this fraction, really? Well, what's this fraction? Well, this is the equivalent to 1. Something divided by itself is 1. So I'm just timesing the fraction effectively by 1. Anyway, which is why it doesn't change. The main thing is, if you've got a surd in the denominator, to rationalize it, times it by itself, but times the top by itself as well. Well, you know, by that surd. So what am I going to times this roots by to turn it into a whole, into a rational number? I times it by itself. I'm going to times the top and the bottom by root 7. 1 times root 7 is root 7. Root 7 times by itself is 7. Okay, the denominator is now a rational number. That makes sense to us mathematicians. Oh, what's here though? We've got a whole number and the root 5. We've got 3 root 5. So what do I times it by now? Do I times it by 3 root 5? Do I times it by root 5? What do I do? I could times it by 3 root 5, but actually I don't need to. All I'm trying to get rid of is the square root, so that's all I need to multiply it by, because that will get rid of the square root. Yeah. Okay, what do we get though? We get 3 root 5 times root 5. Well, root 5 times root 5 is 5. So effectively we end up with 3 times by 5 underneath. Now the top is quite clearly 1 times root 5 is root 5, but the bottom simplifies a bit more to 15. You could have done that in one step, but I've written it out to try and explain it. The root 5 times root 5 gives you 5, and of course we got 3 lots of that, so it's 15. Last one. So here again, remember I don't need to times it by 2 root 8. I could, but I will end up having to simplify my fraction later on. I don't want to do that if I can avoid it. So I'm going to times it by root 8 and see what happens. Just times it by that surd. Well, 4 lots of root 8 is 4 root 8. And underneath we've got 2 lots of root 8 times root 8. Well, root 8 times root 8 is 8. And we're going to times that by 2. So I have got 4 root 8 over 16. Okay, well, firstly, some things can simplify here straight away, can't they? We can divide the top and the bottom. Let's get another pen colour out. Just ordinary fraction simplification here. Divide the top by 4. Divide the bottom by 4. And I will end up with 1 on top, so 1 lot of root 8. And 16 divided by 4 is 4. Okay? But sneaky people that wrote the question forgot that, of course, root 8 can be simplified because it's the same as 4 times 2. That's a square number, which means we can remove it from the surd. My computer really is being very frustratingly weird. And that equals 2 root 2. So on top, we could actually go a bit further. We could have 2 root 2, which means I can simplify again, because both the top and the bottom will divide by 2. So I'm going to do that. Let's go back to the blue. To get 2 divided by 2 is just 1, so that's now 1 lot of root 2. And 4 divided by 2 is 2. Whew, blimey. I could have probably escaped some of that if I'd first of all noticed that I could have simplified the 4 and the 2 straight away. But anyway, you get the right answer in the end. Your turn. There are 6 questions for you to have a quick go at. Off you go. Unpause it when you are done. Okay, we have unpause. Sorry, I had to slurp a drink there, which probably sounds horrible over the mic. What are we going to times it by? We're going to times it by root 5 underneath and by root 5 on top. So 11 lots of root 5 over 5. Can I simplify it? No, I can't. Good, job done. I'm going to times this by root 3 underneath and root 3 on top. So we've got 2 lots of root 3 over 3, because root 3 times root 3 is 3. Can we simplify it? No, we can't. 14 over root 3. I'm going to, ooh, why have I put an equal sign? I haven't done anything yet. Times it by root 3 underneath and root 3 on top. 14 lots of root 3 all over 3, because root 3 times root 3 is 3. Let's see what we've got here. So let's times this by root 2 underneath and by root 2 on top. So 12 lots of root 2. And root 2 times root 2 is 2. Now look, we can simplify this, because 12 will divide by 2 to just get 6 lots of root 2. And, oh, don't put my ticks. Here we go. 2 lots of root 2 underneath. And we're going to times it by root 2, top and bottom. So 10 lots of root 2. All over root 2 times root 2 is just 2. And this will simplify as well, because we can halve 10. So we do divide it by 2 to get 5 lots of root 2. And lastly, we're going to times this one top and bottom by root 5. We've got 15 lots of root 5. And root 5 times root 5 is 5. Oh, look, we can divide this as well, because 15 will divide by 5 to give 3 lots of root 5. Right, well done if you got those right. Let's make it a bit harder. Yay, says everyone. What if I've got a couple of things on top of my fraction then? Okay. Now remember, what we're really doing is timesing this by a fraction, aren't we? And this fraction, in this case, to rationalize that denominator, it would have to be times by root 5. And I'm going to do that on top as well. At this point, if you've got more than one thing together, I would think of it as being in a bracket, because you need to times both of those things by the root 5, not just one of them. So we'll do root 5 times 2, so we get 2 root 5, plus root 5 times root 3. Now remember, when we're timesing square roots together, they can go into a single square root, just like rule 1 up here. So that will be root 15, which doesn't simplify. And then that's all over 5. Yeah, so the only difference here really is you've got to remember to multiply everything on that layer by the root 5. And putting a bracket around the first fraction kind of helps you visualize what's going on. Let's try it again. God, this is starting to look a bit tricky, isn't it? It's like proper maths. Right, so what are we going to times it by? I'm not going to times it by 2 root 2. I'm just going to times it by root 2 top and bottom, just like timesing it by a fraction of this. And so that's root 2 times by all of the original top of this fraction, all over 2 root 2 times root 2. Well, that will be 2 times by root 2 times root 2 is 2. So my new bottom of my fraction will be 4. Let's have a look at the top. Okay, root 2 times 3. That's 3 root 2. And root 2 times 5 root 2. Well, remember, the root 2 times the root 2 will be 2. And we'll times that by the 5 to get 10. All right, I'm just going to say that again. Root 2 times root 2 is just 2. And we'll times it by the 5 to get 10. Okay, we can't simplify by dividing everything by anything particular, so that stays as it is. And lastly, I'm going to try and write a bit neater this time, because my writing's getting really bad. Let's times it by, well, it's quite straightforward, this one, isn't it? Root 2 on the bottom and root 2 on top. Whatever you do to the bottom, you must do to the top. Remember, it helps if you imagine the top in a bracket there. Remember, when you're multiplying fractions, you multiply tops, multiply the bottoms. So we'll multiply all of that by root 2. And the bottom we can do straight away. Root 2 times root 2 is 2. Okay, let's multiply out. Right, root 2 times 5. Well, just like x times 5 would be 5x, this is 5 root 2. The number, like, whole number comes first. And then take away. Right, root 2 times root 2 gives me 2. And we've got 2 lots of that, so we've got 4. All over 2. Okay, Let's just run past that last little bit there. Root 2 times root 2 is 2, and we've got 2 lots of that, so we've got 4. Yes, slightly trickier. Right, there are 4 for you to do, so pause the video and off you go. Sorry, I'm drinking on microphone again. It's horrible, isn't it? Right. We have unpaused. So let's go for it, because we've still got a bit more to cram in yet. Okay, we're going to times this by root 2 underneath. Let's speed up the explanation so we get on to the next bit. And I'm going to go straight for the answers. Root 2 times root 2 would be 2. And remember, I'm going to multiply all of this by the root 2, so I'll have 10 lots of root 2. Plus, now root 2 times root 2 is 2, times it by the 7, you get 14. Right, I'll give you a mark if you've got all of that, but notice that all of these numbers will divide by 2. So you can halve the first bit, so 5 root 2, and you can halve the second bit to get 7, right? If you got this one, I'm really pleased, but if you also noticed you could actually simplify it as well, you could divide by the 2, then, you know, happy days. Oh, I keep putting the equals before I've done anything. Right, and that's times this one by root 7 on the bottom and root 7 on top. But I'm going to keep in mind that that can also be, you know, it needs to be multiplied by all of it. So I'm going to put it in a bracket to help me visualize it. Right, root 7 times root 7 is 7. What on earth is that line? That's very slopey. 9 lots of root 7 then is 9 root 7. And I've got root 7 times root 7 is 7. Times by the 3 is 21. And we're going to take that away. I can't simplify because they don't all divide by the same thing. That's really terrible, isn't it? That slopey line. Maybe put your laptop sort of on a little chalk so it's slightly slanted. Anyway, right, moving on. Times that by root 2, times that by root 2. Let's see what we get. Root 2 times root 2 is obviously 2. And I'm going to times it by root 2 times 3 is 3 root 2. And this one, so root 2 times root 2 gives me 2. Times that by the 3, and we get 6. Can I divide it all by the same number? No, I can't, so that's done. And my last one, root 3 times by top and bottom. What do we get? And I'm going to put that in a bracket so I can visualize it. Right, root 3 times root 3 is 3. 7 times root 3 is 7 root 3. Now, root 3 times root 3 is 3. Times by the 4 is 12. And I can't divide those all by the same number, so it stays as it is. Good. Right, last little bit then. Now this bit is a bit trickier, because now my denominator has 2 parts. It has a rational part, so that's a 6, and an irrational part, which is my surd. Right, now, this is where we need to multiply it by something different. We multiply it by what we call the conjugate. Now, I would put a bracket around this, because that will help you visualize what's going on. I am actually going to do a little bit of foiling here, and I'm going to times it by this. See if you can spot the difference between my denominator and the bit I write. All the same so far. Look, different sign. This is what we call the conjugate. It's basically the same thing, but with the opposite sign. Whatever that sign is, you need to multiply it by the opposite sign. And it's just like when we do the difference of 2 squares, because it's the same thing but plus and minus, the bits of it will disappear. The irrational bit will disappear. Now the first one I'm going to write out in full. The second time, we'll see. Depends if we got the time to do it. Right. I need to FOIL the bottom of this fraction. So I'm going to do first 6 times 6 is 36. Let's write FOIL up here so I don't forget. FOIL. I'm going to do outers. So 6 times minus root 5. So that would be negative 6 lots of root 5. Inners. 6 times root 5, they're both positive, so it's 6 root 5. See what's happening yet? And lasts, root 5 times negative root 5. Well, root 5 times root 5 is 5. but one of them is negative, so it's a negative. Look, these two middle bits are going to cancel out. If I just change my red pen so you can see, look, I've got 6 root 5, take away 6 root 5. They cancel out to disappear. Right, that's what happens. So we've got 36, take away 5, which is 31. And the top bit is still 8. So actually my surds have completely disappeared on this one. My denominator's rational and the top... Oh, of course. Idiot. What have I done? Of course it should. I was thinking it shouldn't disappear. What's happened? Because, of course, what I do to the bottom, I must do to the top as well. Apologies. Unfortunately, I can't delete part of the video, so we're going to have to stick with that. I can't believe I did that. Mr. Nice, what are you thinking? Right, and okay, so we're going to multiply this out, and it's going to look really scrappy and horrible. Maybe, could we persuade the eraser to work? It sometimes works. Look at that, it's worked. Yay, we can make it a little bit neater. Okay, apologies. Right, of course, what you do to the bottom of the fraction, you must do to the top. So I'm going to times the top by 6 minus root 5 as well. Okay, right. So 8 times 6. Oh God, I hate 6 8s. 36, 42, 48. 6 8s for 48. I have a blind spot around 6 and 7 8s. And then 8 times negative root 5 is minus 8 root 5. Okay, so the top bit's not particularly hard. I was thinking that's weird that the denominators, the surd has disappeared completely. How strange. Let's write that a little bit neater over here as well. So 48 take away 8 root 5 all over 31. Whew. Okay, let's try and get it right the second time. What am I going to times it by? I'm going to times it by the conjugate. I've got two things down here. Now, it's not just 2 root 2, it's 2 plus root 2. I have a rational part and an irrational part. So I need to make sure that I have times all of this by the conjugate. It's the same thing, it's still 2 and root 2, but it's 2 take away root 2. Just change the sign. And what you do to the bottom, as we all know, you do to the top. Okay, FOIL the bottom then. Firsts, 2 times 2 is 4. Outers, 2 times negative root 2 is negative, negative 2 root 2. Inners, 2 times root 2 is positive 2 root 2. And that's what we want because they're going to be opposites, so they will disappear. And then root 2 times negative root 2 is negative 2 because it's root 2 times root 2. If anyone ever makes a mistake with these, it's nearly always that when you do root 2 times root 2, you just get 2. Remember, these middle bits will cancel out. And so you get 4 take away 2 is 2. Let's try the top then. 13 times 2 is 26. And 13 times negative root 2 is negative 13 root 2. I'm going to have a little look at my computer later and find out why it's doing this. Right, 26 take away 13 root 2. Now I can't simplify that because although the 26 divides by 2, the 13 doesn't. And we want whole numbers here. So we just leave it like that. And lastly, let's make a real effort to write this neatly. I have got 2 things on top and 2 things underneath as well. So let's put our brackets in because it helps us visualize what we're doing. And I'm going to times it by the conjugate of the denominator. So that's still 3, and it's still root 2, but it's 3 plus root 2. And then on top, we'll times it by the same thing, 3 plus root 2 as well. Yeah? Okay, FOIL. We'll have to FOIL top and FOIL the bottom as well. Right, firsts, 3 times 3 is 9. Outers, 3 times positive root 2 is 3 root 2, just positive. And then inners, 3 times negative root 2 is negative 3 root 2. And then last, negative root 2 times positive root 2. Well, it's negative and a positive, so it will be a negative answer. And root 2 times root 2 is 2. Remember, these middle bits are going to cancel out because it's plus and minus are the same thing, which means I've now got my new denominator of 9 take away 2, which is 7. That's definitely rational. Okay, top though, but I need to FOIL this as well. 6 times 3 is 18. Outers, 6 times root 2 is 6 root 2. Inners, 3 times 4 root 2. Well, 3 times 4 is 12, so it's 12 lots of root 2. And 4 root 2 times root 2. Well, root 2 times root 2, remember, is 2. And we've got 4 lots of that, so that's 8. And let's put some things together. 18 plus 8 is 26. And 6 root 2 plus 12 root 2 is 18 root 2. So these ones do take a bit longer, don't they? Okay? Well, and they can be tricky. Just remember, it's the conjugate. If you've got a rational and irrational part on the denominator, you times it by the same thing, but change the sign. Whatever that sign is, change it because it will make it work. It will make those bits disappear, the square roots disappear. 4 questions for you to do, and then unpause, and I will rattle through the answers much quicker this time. Off you go. We have unpaused, he says slightly wearily, because this is a long video, isn't it? But I do like surds. I am a big fan of surds. They're good fun. Yeah, no, they really are. Shush. Right. The conjugate then, in this case, will be 8, and it will be take away root 2. Now, I haven't got a lot of space, so I am going to do this sort of the shorthand version. And 8 take away root 2. Now, the top is the easier bit to get right, because I've got 7 times L 7 8. That's 56. I'm so bad with 6 and 7 8s. 7 root 2. Okay, should have got that on top. And underneath, we're going to have 8 times by 8, which is 64. And I'm going to do the shorthand version here, because you would have had positive 8 root 2, negative 8 root 2. They would have disappeared, leaving you with root 2 times root 2, which is 2. And we can simplify that to 64 take away 2 is, of course, 62. So you should end up with 56 take away 7 root 2 over 62. Good. Okay, this one we have got, we are going to times it by the conjugate, which is 3 take away root 7. It's the same thing, just with a different sign. And of course, we do the same to the top as well. Right, okay, so let's do some multiplying on top. 5 3s are 15, and then 5 lots of root 7 is 5 root 7. And of course, that was negative. Underneath, let's FOIL. 3 times 3 is 9. And then I'd end up with 3 lots of root 7 and negative 3 lots of root 7. So that will disappear eventually. Take away root 7 times root 7 is 7. So we have 15 take away 5 root 7 all over 2. Because 9 take away 7 is 2. Right, okay. Oh, I've put the equal sign. I've got a bit of a habit of doing that, haven't I? I haven't actually times it by anything yet. And let's times it by the conjugate again, which is 3 take away root 2. And we're going to do the same to the top as well. And that will equal... All right, let's do some multiplying out here. 4 times 3 is 12. 4 times negative root 2 is negative 4 root 2. And let's FOIL the bottom. 3 times 3 is 9. And then, of course, I've got 3 lots of root 2, negative 3 lots of root 2, which will cancel out eventually. Take away root 2 times root 2 is 2. So we're left with 12. Take away... God, the pen is being funny today. 4 root 2 all over 7, because 9 take away the 2 is 7. And one last one, I'm sure you'll be pleased to hear. We're going to times this by 5, take away root 5, 5, take away root 5, and then we're going to multiply the tops, multiply the bottoms, aren't we? 6 times 5 is 30, take away 6 lots of root 5, and then foiling the bottom, 5 times 5 is 25. And we'd end up with 5 lots of root 5, negative 5 lots of root 5, which would cancel out. And then negative root 5 times positive root 5 is just 5. So our final answer is 30. Take away 6 root 5 all over 20. Okay, apologies about that little confusion in the middle there, but we did get it right in the end. Okay, what I'd like you to do now then, spend the rest of the lesson choosing which ones of these to do. Okay, you've got bronze questions, silver questions, and gold questions. I'd say that, yeah, they are definitely bronze, silver, and gold this time. You choose. You do as many as you want to fill up the rest of the lesson. And then let me know how many. If you did bronze, tell me you got 5 out of 6 bronze. Or if you did silver, I got 3 out of 6 silver. Or if you did all 3, if you want to do all 3, that would be fantastic practice. It really does help. I hear people go, no, no. Then, you can tell me how many you got on each particular banding. All right. You could also just choose. You can just do straight for gold if you don't want to do bronze and silver. But make sure you know what you're doing if you do. Okay. So pause the video now to do as many as you want. And then unpause. The answers will be there in a second. So pause now. Okay, I have unpaused and the answers are going to come up in a second. So are we ready? Here come the answers. Here they come. There you go. So you can pause the video again and do your marking. So well done.